Roger, copy.
All right, we're live. Hey, Alan, how's it going?
Hey, it's good. How are you guys?
Good, good. Yeah, really excited to have you here for another MoonDAO Town Hall. Yeah, I wanted to, I guess, first dive into your background. So you grew up in Louisiana, New Orleans, and I'm curious, how did it all start? Why did you get into astrophysics and studying the cosmos? What inspired you when you were younger?
Well, I don't remember the earliest origin, but I do know that ever since I can remember, I was interested in space and astronomy. And when I was very, very young, I wanted to grow up and be an astronomer. Later, by the time I got to college, I narrowed that down to wanting to be a planetary scientist. But I wanted to be an astronomer and astronaut. And, everything that was going on in the early space program was exciting to me. And I just wanted to see how quickly I could grow up and become a part of it.
Yeah, I mean, was it so I guess you've kind of taken both paths. You've both been an explorer, so you've gone into suborbit with Virgin Galactic. You've gone and explored the Titanic, but then you've also been a scientist and part of NASA SMD and private and public initiatives. So I wonder, I guess, did you want to become an astronaut or a scientist or both? Was it, what was the main inspiration, I guess?
Well, when I was very young, I wanted to be an astronomer. But around the time that I was 9 or 10, I thought I would be much better suited to being an astronaut. And I pointed a lot of my career and education and career experience to get the skills to do that. As it turned out, I was interviewed by NASA and went through all the physicals and psychological exams, but was not selected to be a space shuttle astronaut. And then the commercial space industry came along, and there was an opportunity to fly in space, which I've done once, and I'm looking forward to doing again. And so I've had a chance to fly, and I'm looking forward to a lot more flying in future years.
Yeah.
But I've also been a scientist my whole career. I have led many scientific investigations and missions and published hundreds of refereed papers in the literature. So it's really been a dream come true to get to do both those things.
Right. So I guess I have some stats there. So when you're at SMD, the budget that you were responsible for was over $4 billion.
Over $5
billion. Oh wow. Okay. So portfolio of 93 flight missions. Hopefully these stats are correct. 3,000 research grants, and you implemented reforms that reduced the cost overruns by 63%.
Those are all good numbers as far as I know.
Okay. So I guess what was it like being at the helm of such a large budget? And I guess I'm sure doing any sort of reform, especially one that would reduce budget overruns by over 50%. That must have been a huge effort and initiative. I'm curious what sort of what mindset did you have going in? What did you learn, and how were you able to implement those changes?
Okay, I just counted 6 questions in one, so I'm not going to remember all 6.
Okay.
You need to ask me 1 or 2 questions at a time, or I'm going to be terrible at the batting average, keeping your list in my head while I'm also trying to answer.
That's increasing surface area.
So let me start with saying that SMD is an amazing organization. The United States leads the world in all of the space sciences and in Earth science. And Science Mission Directorate is the home for all of that. Of course, the United States also leads in human spaceflight, but my corner of NASA was the third of the budget that was, at that time, Science Mission Directorate. And a lot of very talented and dedicated people there. running that program. Of course, I was the top of the food chain, and really honored to be able to do that. It was a lot to learn in a short period of time to get my arms around, multiple different programs for planetary exploration, astrophysics, earth science, heliophysics, technology development, all those things. And the whole grants program in each of those domain areas, in addition to the 93 flight missions that were either flying or in development. So it was a job that required a lot of bandwidth. A lot of other people have done that job and done it very well since I've been there, and people did it well before I was there. And I think they've all enjoyed the challenges and the responsibility and, frankly, the chance to make a difference. Part of my making a difference was set by the fact that at the time I was at NASA, there was a ground rule that we were not going to get more budget, that we could not increase the science mission directorate budget. So my feeling was that we should try and get more out of the budget that we have, that we should look for efficiencies so that we could fly more missions and do more good, produce more science. What we found pretty quickly by doing analysis was that about 20% of the SMD budget back then in 2007 was being chewed up by overruns in flight programs. A lot of things cost more than had been anticipated, but there were also some pretty bad program management feedback loops that when organizations came for more money, they almost always got it, which produces psychology that if your cost estimating isn't good, you can fix it later. And if you run into problems beyond your ability to solve them, you can come to SMD and just petition for more funds. And so we turned that around, as you quoted the numbers, pretty severely in just the space of a year. And I'm very proud of that because we were able, as a result, to start 10 new scientific missions, which was a record at that time. Not that many had been started in a single year or anything like it. There had not been 10 missions started in the previous 3 years before I was there. So we were able to really open up a lot of new possibilities by being more efficient with the money that we had and causing missions to find ways to solve their own problems whenever they could, rather than coming to us, because oftentimes they got a no from us.
And so, I guess, could you maybe walk us through the anatomy of maybe the finances of how these projects worked and how you changed them? So I guess, how does it usually work? So say I propose a new mission. It's going to cost $100 million, and I have a timeline. And so you're saying that the majority of those missions were going over the timeline, over the budget, and then they could usually go back to SMD and get the money.
I didn't say the majority of them are, but many of them were. And I don't have that statistic in my head. It's 15 years ago. But right. We had very large cost increases on a wide variety of missions in development, from small missions to big missions, and from missions run by different NASA centers and by industry. There was just a culture that if you exceeded your reserves and you needed more money, you came to SMD and made a case, and SMD usually said yes, and never looked at canceling projects or restructuring them in order to stay within budget. And that had developed this culture that you can just always solve your problems because they will always open the checkbook. The problem with that is that it's inefficient. It means that a lot of projects are not getting started that should be started because other projects are overrunning and taking the budget that's necessary to start the new ones. So in effect, the projects that were having problems were preventing the success or even the initiation of new projects that had not caused any problems. And that's not an optimal way to run any business. So we tried to change that culture and that psychology, and we were pretty successful at it. We did have to cancel some things. We had to be very strong in going to organizations and saying, there's not any more money for you. You're going to have to tell us what you're going to change within your plan so that you fit within your existing budget. And in some cases, we did increase the budget. There were things that just came out of nowhere, like a hurricane that hit a site, and things that were really not within the capabilities of budgets to forecast or control. But we also were able to, as I said, reduce overruns dramatically. And as a result, we could start new missions at a pace that hadn't been seen in a long time.
Right. And well, I guess one of the missions that you're the primary investigator for New Horizons. I suppose we're at the 10-year anniversary of New Horizons, and or a little bit beyond that.
Well, we're at the 10-year anniversary of the flyby of Pluto.
Got it. Yeah.
2015, which is the primary mission target for the mission in its first phase. Since then, we've been exploring the Kuiper Belt, but we can talk about that if you want.
Yeah, I'd love to. Maybe you can start by just giving us a general background about the original objectives of New Horizons. How did it come into being, and then how did it evolve over time?
Okay, you're doing better. That was only 4 questions. Why don't I just tell you a little about it? Back in the late 1980s, when the Voyager program was finishing exploration of the giant planets, there was a push in the scientific community, the planetary science community, primarily by young scientists at that time, who saw a lot of value in exploring Pluto, which Voyager could not get to because of the trajectory that they chose to fly by the giant planets. And it took a long time to build the case, and eventually to have NASA and the Congress and the administration agree to it. It took about a dozen years, but by the early 2000s, there was alignment that flying a mission to Pluto and onward to the Kuiper Belt, which was not known in the late 80s. This is the third zone of our solar system beyond the giant planets. That the exploration of not just Pluto, but Pluto and the Kuiper Belt should be top-tier priority. In fact, the first planetary decadal survey that came out of the National Academy ranked the exploration of the Kuiper Belt and Pluto #1 on the runway for funding. So NASA had a competition, as it often does, where it says, this is the mission we want to do. Who wants to propose to carry that mission out? And different NASA centers or industry or combinations of those wrote proposals. There were 5 proposals to carry out the Kuiper Belt Pluto mission. NASA went through a very detailed, and these proposals, by the way, are 1,000 pages thick, with technical plans and cost and management plans and lots of detail. NASA goes through them with a fine-tooth comb and teams of experts who evaluate the different proposals to determine which one they want to go with. They selected our team, New Horizons, which is a team led by my institution, the Southwest Research Institute, and Johns Hopkins Applied Physics Laboratory. And we were selected in November of 2001 to be NASA's Pluto Kuiper Belt mission provider. And I'll skip a lot of detail, but after a very hectic 4 years and 2 months, we launched that mission in January of 2006 on a trajectory to first Jupiter for a gravity assist, and then on to Pluto, and then the Kuiper Belt. And that's the trajectory we're still on, and still exploring the Kuiper Belt at this time. The mission's been completely successful. Every one of the original objectives have been accomplished. The spacecraft is in nearly perfect condition. It's hard to tell, even that it's not right out of the box the day after launch, other than we've been on a dwindling power and fuel supply because we use fuel up and the power is provided by a radioactive nuclear source that has a half-life, so it produces less power every year. But it's really been a dream mission. It's changed our understanding, not just the Pluto system, but also how planets get their start, how planetesimals, which are the building blocks of planets, form. It's explored the Kuiper Belt and discovered all kinds of things about other Kuiper Belt objects. And we're hopeful that through ground-based telescopic searches and eventually space-based too, that another flyby target is in our future.
I'd never heard that term before. It's a planetesimals. Yeah.
Well, you can Google that term. It's a very common term in planetary science. It means the little things out of which the planets are built, the building blocks of planets. And they're all over the solar system. Comets and asteroids are, in many cases, leftover planetesimals, but they're not as well preserved as the ones in the Kuiper Belt, simply because the Kuiper Belt, being very far from the sun, beyond the orbit of Neptune, and even far beyond the orbit of Pluto, more than 2, perhaps 3 times as far away as Pluto at the outer edge, the Kuiper Belt is much colder, which acts to better preserve the chemistry and the original constitution of these objects, their original form. But also, the population of bodies in the Kuiper Belt is much more rarefied. Even though it's a very large population, the objects are far between each other, and collisions are rare. Whereas in the asteroid belt and other populations, collisions are common. And so as a result of both the cold and the much more benign collisional environment, the Kuiper Belt is the best archaeological dig, if you will, into the history of planetesimal formation that we know of. And so New Horizons flew by one of those ancient, well-preserved planetesimals in 2019 as our first Kuiper Belt object flyby. And the imagery and spectra and other data types that we gathered taught us a lot about how those bodies form and really revolutionized our understanding of that formation process, settling what had been a 40, almost 50-year debate about how these objects get their start.
Well, you've been a part of a couple debates, one in particular around Pluto and its demotion from planet.
I have to laugh about that because, of course, it's funny that someone like you, who's knowledgeable about space, would call it that. You know, most scientists, most planetary scientists, don't buy what the astronomers came up with for a planet definition. I'm among the majority in that. And we just ignore what the astronomers came up with because it's pretty flawed in terms of a planet definition. And you can see that all through the scientific literature, that the demotion of Pluto really doesn't exist among experts in planetary science.
Right. If I recall correctly, under the definition that they provide, Earth would not be a planet if it were in the same orbit as Pluto.
That shows you how sick. You're correct, and it shows you how sick and flawed that definition would be if people adopted it. That's why it's not adopted. It doesn't make sense, and this is not like passing a law. The astronomers have no way of enforcing this bad idea. So people just ignore it.
Mm-hmm. And so does this have repercussions? I mean, you know, the way that we name things or categorize things, I wonder, does this have an effect on NASA budgets?
I don't think so. There are plenty of missions to objects that planetary scientists call planets that astronomers would not, such as the moon Europa, where we now have a multi-billion-dollar mission headed that way, such as the interest in going back to Ceres, the interest in going back to Pluto, the interest in flying missions to Uranus and Neptune, the ice giants, which themselves the astronomers and planetary scientists both call planets, but they're satellites. They're very large satellites like Triton that orbits Neptune. They have very high scientific interest in this business about sorting in bins and categories. Doesn't really affect things like decadal surveys that set priorities.
Right. And so when it comes to Europa, you've proposed a very interesting solution to the Fermi paradox, which is that the majority of life is subsurface. I was hoping that you could expand on that a bit more. And
I can, but I want to refine the way that you stated it. I did not propose in my paper, my research paper, that the majority of life lies in subsurface ocean worlds. What I said was that if complex life evolves in these ocean worlds, it's very hard to know it's there. And so you could have civilizations beneath the ice roof in these ocean worlds, and we would never know about them because their radio signals and optical signals don't get out through the miles and miles and miles of ice that lie above the oceans. They're very stealthy, and for that reason, perhaps the answer to the Fermi paradox, that is the question Fermi posed in the mid-20th century, asking if there's so many stars, why don't we see civilizations everywhere? Perhaps the answer is because they're primarily in these kinds of stealthy ocean worlds beneath roofs of rock and ice that don't allow us to see them. And that's just a speculation. I think it was a well-reasoned scientific argument. It might be right. It might be part of the solution to the Fermi paradox or all of the solution, and we really don't know. But it was a novel idea, and it was fun to develop it and take it through the process of getting it out into the scientific community.
Right. And so what should we be looking for when it comes to answering the question of whether there is life subsurface? So you mentioned miles of ice. Is it even possible to test the hypothesis? How would we? What are the best ways to figure out whether or not there's life on Europa?
Well, Europa and the other ice world, the world's icy worlds that have liquid water oceans, they're all over our solar system, and we expect they'll be all over the galaxy in other solar systems. Even Pluto is one of them, very far from the sun, with what is almost certainly a liquid water ocean deep beneath its surface. And so is Enceladus, and so is Triton, and so is Titan, and we could go on down the list. I think there are over 20 worlds that we believe could have oceans, like Europa is known to have, and Enceladus is known to have, for which we either have modeling or actual physical evidence for those oceans. In the case of Europa, it's the closest, and it's about to become the best studied of all those ocean worlds in our solar system, because the Europa Clipper mission, which NASA launched a couple of years ago, is on its way there. It'll be several years before it arrives, but it's coming with this very sophisticated battery of instruments to better understand the nature of that ocean and to better understand the stuff that's in the ocean, not the biology, because it's not a mission to the surface. It's a mission that's going to study the ocean through remote sensing techniques with cameras and spectrometers, and then study things that come out of Europa in these plumes and in the atmosphere of Europa with techniques like mass spectroscopy and others, to prepare us for a mission that would later be built to go to the surface and eventually to have missions that penetrate down through all this ice, whether they go down in crevasses or whether they drill or sink scientific spacecraft down into that ocean. I think that's something that will happen later in the 21st century, so we can have a look at what's down there in terms of biology. And it may be none, and it may be teeming with it. We can't tell the answer to that question with Europa Clipper, but what we can tell is how to build a lander and whether the case for biology is strong enough to justify what that would cost.
Right. And I guess where do you land on the idea of aliens? It's always fun topic to speculate on. So I guess do you put any weight to any of the things that people report, say here on Earth, or do you have any interest in this type of stuff, or do you think it's all baloney and nonsense?
Well, there are really two questions in your one question, and thank you for one question. There's a question of whether I think that there is life elsewhere in the universe, and my gut tells me that we should expect that. We're a long way from having detections, but the universe is vast, and so the dice get rolled a lot, and it seems to me preposterous that the Earth is the only place where life has likely got to start. In fact, I wouldn't be surprised to find that life is very common, at least simple life forms, across the planets of the galaxy, and maybe even on places that aren't planets. We'll see. But with regard to UFOs, which I think is really what you were mainly asking about, I think that I have not seen any compelling evidence that they're really spacecraft from civilizations that have crossed the galaxy to come to the Earth. That doesn't mean that they're not. I said that I haven't seen any compelling evidence. What I think we need to do is to move the ball forward in this from anecdotal reports and accidental sightings of things to really set up networks of sensors, cameras, and spectrometers, and magnetometers, and other kinds of sensors that can spot these things we currently call UFOs and determine what they really are. Even if most of them are junk, if it turns out that any of them are spacecraft, that would probably be the biggest scientific discovery of the age. But whether or not that's so, I don't know. And no one's really going to know, I think, until we do a first-rate job of investigating this problem scientifically, and not just by accidental sightings by pilots or people on the ground with their phone cameras or their video cams or whatever. They're not real scientific instruments. And people have talked about, I'm not the first to come to this idea, but I am enamored with it, that we should turn this into a scientific pursuit and see what's really going on. That's going to take money, and it's going to take perseverance. But I think we know how to do that, and I would love to see such a program get funded.
Yeah, I think I share your perspective. I wish there were just more hard evidence or anything that the research community could really dive deep on. And it just seems like these anecdotes and stories just aren't really enough to form any sort of scientific basis.
Right, and that's the dilemma here. Is we have lots of things that might be interesting, but we won't know as long as we rely on accidental sightings instead of, how do we solve any problem in astronomy or the sciences when we discover a new phenomena? Researchers make hypotheses about what is behind that phenomena, and then they create experiments. In astronomy, we use telescopes and different kinds of sensors to suss out what has turned out in the past to be things like the discovery of quasars, the discovery of black holes, the discovery of fast radio bursters, the discovery of magnetars, the discovery of phenomena in our own solar system, because we applied the scientific technique and resources and we gathered data about it, and we eliminated some hypotheses and found that others grew stronger and stronger, and we modify our ideas with new data. until we reach a paradigm of understanding. And nothing like that has really been done with the UFO problem. I know people are trying to do that now, and I applaud that. And let's see what the data tells us when they get funded and start collecting the data that's necessary to tell us, to turn this into a scientific problem instead of just accidental sightings and stories.
I wanted to ask a bit about your involvement in the private side of the space economy. So you were CSO at Moon Express, I believe, and Worldview, and have advised a number of different organizations. I wonder, what's your perspective on kind of the evolution of space becoming something that is funded primarily via public funds, and now where there's kind of becoming there's commercial companies that are getting money from private individuals to fly to space or to participate in the space economy. How do you see, I guess, how do you see this evolving over time? Do you think this is a good thing? I won't ask any more questions because I think
that was 3 already.
Yeah.
I'm counting. Yeah. So let me provide a little context of the way I see it. The exploration of space really got its start in the 20th century as basically a competition between two superpowers who were in a Cold War competition, the United States and the Soviet Union. And of course, many other countries came into it, but in the mid 20th century, the technology to explore space was at the very edge of human capability. And it took enormous efforts involving thousands and even tens of thousands of people to do things that we can today, now having entered the second quarter of the 21st century, we can do with private companies and teams, in some cases as small as dozens to a few hundred people. So the landscape has dramatically changed as the technology has come along. And as a result, flying rockets to orbit and beyond Earth orbit, and building spacecraft to do all kinds of things from science to surveillance, and I don't just mean military surveillance, but agriculture and pollution and global change and shipping and crime and all kinds of other surveillance applications and applications for communications have really blossomed. There's a very well-known firm named McKinsey that analyzes many things. In 2024, they issued a report last year in which they analyzed this global space economy in 2023. They had all the data from the latest year, 2023. They found the global space economy is huge. It's $600 billion in that single year. Now that's commercial programs, civil programs like NASA, ESA, JAXA. It's from every country that is involved in that. And McKinsey estimated all of the resources being put into defense or national security programs, everything. And it's pretty interesting what they found. First of all, $600 billion a year in space efforts is a big number, and it's going to grow because this whole field is exploding with capability and with private capital investment, venture and institutional investment. But most interesting to me was the statistic they came up with that 3/4 of the 2023 space economy was non-governmental, i.e. private. And so we've gone through a revolution back in the 1960s when space got its start in the 50s, and even into the 70s, there was very little that commercial space companies could do. The first big application were communication satellites, and they're still a big application. But now all these other applications have happened, even space tourism, and it's going very rapidly with new applications and use cases every year, many of them. And so we've now reached a point where commercial space dominates all space activity. And I think it'll be more and more so that way. And that makes for a much more sustainable space economy than just relying upon civil and defense programs that come from taxing people. And it's much more like the terrestrial economy, which is primarily private sector, particularly in Western countries. So I think this is all very positive development. I expect it to continue to go faster and faster in the coming years and decades with commercial space development. That'll ultimately, I think, push out all across the solar system, if not further, in the future. And that the Star Trek era, in a couple of centuries, will have government programs alongside commercial programs, but they won't be dominated, in my view, by government programs, except in niche areas where there's not a commercial market.
Right. So there have been recent statements coming out of NASA about putting a nuclear reactor on the moon and creating a base on the moon for national security. I'm curious, where do you land on those developments? Do you think that we should settle the moon? And maybe I'll stop there.
Well, you asked different questions this time about different things. I do think that we should settle the moon and use it for to make life better on Earth. Also, to do pure science, to use the moon as a laboratory to understand itself, just the way that we spend a lot of effort understanding the Earth and the planets, and that humans on the moon will accelerate the pace of scientific discovery. But there are many other use cases for the moon, and that we'll eventually build a lunar economy around it, and that we will start with very small outposts that look like, the population of the International Space Station at a couple of locations, probably in the next 10 years, by the United States and China, and each with a consortium of other countries around them, and that will expand. And over time, just like we're seeing the development of commercial space stations in low Earth orbit, we'll see commercial companies sending humans to the moon for many kinds of uses, from science to energy production to surveillance to tourism, and probably a lot of things we haven't thought of yet because we're not in that era. The same way that when computers started to become proliferating across the economy, people didn't really think of them as social tools the way that we do today. People primarily thought of them as accounting tools and scientific and engineering computation tools, and they still are those things too, but there are all these new use cases, and I think we'll see the same with lunar development. I'm very excited about it. Now, you asked about the administration's interest in nuclear power on the moon. It's just a fact of life that the Earth's moon rotates very slowly, and as a result, any spacecraft on the surface, any base or just a lone robotic spacecraft, has to sustain itself through a 14-day lunar night when there's no sunlight for solar power. And so you either have to have enormous energy storage mechanisms, or you have to bring your power source with you, and nuclear is one way we know how to do that. Or you have to have solar power satellites that beam energy to places on the moon where there are spacecraft or bases. So the solar power satellites sit up high above the moon in space, in sunlight, and beam that power to the ground. Or you have to generate power some way on the moon, for example, from lunar heat flow. That doesn't look to be as efficient as some of the other things I just talked about. So I think it's natural, and I'm a proponent of nuclear power on the Earth for a lot of reasons. And I'm a proponent of nuclear power on the moon as well. And so I think it's going to be a natural development, and I'm glad to see it getting its start.
How do you see the roadmap to the moon evolving, I guess. So it sounds to me like you share the idea that there should be a permanent human presence on the moon. It's going to take a lot of infrastructure to do so. What do you think is the most compelling first step towards permanent lunar infrastructure? Do you think it's the power piece with the nuclear reactors, or how do you see this sort of evolving and progressing?
Yeah, well, I am a proponent of not just human exploration of the moon, but basing of humans on the moon. And that's going to happen whether the United States does it or not, because we know that the China wants to do that, and they're very far along in preparations for the first Chinese human lunar landing that they want to do by the end of the decade or 2030. And I would like to see the United States be the leader in that, but not just to go and return as we did in Apollo, but to go and stay and to grow our presence with more and more people doing more and more things at more and more locations across the moon. For all those things we talked about, science and exploration, and for economic development, and for all the other use cases we haven't thought of yet. And we have to start somewhere, and NASA's Artemis program, which might need to be restructured. There's some inefficiencies there that we could make better. Is a pretty good start, and I'm glad to see that people are taking a hard look at whether we can do it better. But the key thing is to do it. Even if we're doing it inefficiently at first, it'll get better with time. And the most important thing is not to stop and start over, because we're pretty far downstream, but to take what we have and exploit it, because we've invested a lot of time and money in it, and then improve on it to make it more efficient and more useful as we go forward.
Well, we're at the 45-minute mark here. I want to be respectful of your time. Thank you very much for joining us and answering some of our questions. I really appreciate you coming out and being a part of one of our town halls.
Thank you for having me here and asking so many great questions. It's been really a pleasure chatting with you, and it's been my honor.
Yeah, and I'll try not to ask 5 or 6 questions at a time, shotgun approach. But thanks for you answered the majority of them. Actually, you did a pretty good job there.
Well, in baseball, if you bat 400, you're doing really well.
Yeah. All right. Well, I'll pass it along over here to Ryan, and then we'll continue on with the town hall and Discord. Thanks, everyone. Thank you, Alan.
Thank you. Goodbye.
Welcome to MoonDAO, a revolutionary governance model and mission-oriented community that's reshaping collaboration in the space industry. Our mission is to create a self-sustaining, self-governing settlement on the Moon to act as a launch point into the cosmos. MoonDAO is governed like a nation, with its own economy, constitution, voting system, treasury, elections, and senate, but internet native, and so without the limitations of geography. In 2022, we sent our first member to space, showcasing our model's capacity for real-world impact. Now, we're implementing key solutions for global collaboration in the space industry. We offer a borderless, permissionless platform that enables everyday people to participate in the future of space development and exploration. Be part of our lunar legacy and join the MoonDAO movement today.